So I'm going to cover a couple of different use cases today. We've selected a couple that have an impact on human lives. A lot of the things we do in big data are things like optimizing marketing programs, which aren't particularly appealing to a lot of people. So what I'm going to discuss today actually helps people, actually improves people's lives. This won't be quite as technical as some of the ones in the track, but I will overtone and describe kind of the architecture, what's being done, a little bit about the algorithms. One of them is quite proprietary, so I can't get too much into how it's designed, but we will discuss that. So 2 use cases, that's it. And I'll give some background too on why I think these are relevant. So the first one is in the healthcare space, and the reason this one is relevant is simply because of the great problem of, in the US at least, how to provision healthcare for a diversity of socioeconomic brackets, great amounts of poverty in parts of the country, how to deal with Obamacare and make that effective. So this company, United Healthcare, is the largest payer, as they say, they're the largest insurance provider for healthcare in the US. 200,000 employees, it's quite a big company. It's actually one of the top, I think it's top 5 or top 6 companies worldwide, so it's a big company. And in this case, they were able to, with the use case I'm going to describe, shave billions off their payments and shift that over to affordable care programs. So we'll show you how they did that. So a bit of background on this. This isn't going to look terribly dissimilar from a lot of countries. The cost of healthcare just keeps going up. Nobody seems able to stop it. It's inexorable. There's a lot of different contributors to that. Obviously, you know some of them: aging population, the increasing cost of prescription drugs, expensive operations, and so on. So there's a lot of different contributors, and some of these can't be changed. There's just nothing we can do about them. Aging population is not something you can turn on a dime. That's something that even with government programs that encourage various things, that's something that takes decades and decades to change. So some of this can't be changed, and yet where the U.S. is today, it's quite in a problem spot in terms of how much that healthcare spending represents a portion of gross domestic product. So today, that's just the healthcare spending alone in the U.S. equals the economy of the entire UK or France. So it's getting to the point where something needs to be done to kind of reverse that. Obviously, the Affordable Care Act in the US, or Obamacare, was rolled out, but although it's slightly changed the trajectory of healthcare spending growth, it hasn't actually decreased it significantly. Now that may happen. The program is still, in terms of the lifetime of these programs, it's still relatively new, so we still expect changes to happen. But having said that, that's becoming a problem. We can't have it eat up the entire GDP of the country. So who's making money? Pharmaceutical companies are making quite healthy profits, right? Upwards of 20%. You probably expect that. And you might say, well, it's those insurers. Those are the ones that are stealing the profits, but that's not the case. From having worked in retail once, I can tell you the margins there are about 2%. So these are 50% higher than that, 3%. Not very good. And so any money that is excess that is spent, it's not going to come out of those profits. It's going to come out of increasing premiums for those that can least afford it. This graph will make it particularly clear. So this is an analysis divided out by where is the spending going. And if you look at these figures, the top 5%, that represents just an enormous amount of the spend. It's half of the spending. And it gets even worse. The top 1% is 1/5 of the spending in the US. Now, you could look at that and say, oh, that's obviously where the cuts have to come from. Except that's the sickest patients. Those are the people that actually need the healthcare the most. And so you can't just go cut there. You have to be much more clever about how you save the money. So we kind of alluded to this before. Where is the money going? Some of it is prescription drugs. And the key thing to note is some of these are needed, but some of these also are being prescribed where they're not needed. And I think it's well known that in the US, one of the biggest violators of rules against prescription of antibiotics, for instance, where they're not needed, US is one of the biggest in the OECD for overprescribing them. And this happens because the patient has a direct relationship with the doctor who has a direct ability to prescribe a drug, but the patients are aware of which drugs are available and often push to get a particular drug. So they're not walking in saying, I've got a headache. They're walking in saying, I need ciprofloxacin now. So they're pushing to get a particular drug. That's often where costs go up. Surgeries. I think we know today that a lot of surgeries can be done less expensively using arthroscopic methods, sending a tube into your body to go fix something. There are a lot of surgeries where it could be done that way, or it could be done in the messy way, in the expensive way, and often does get done that way, even though it doesn't have to be. There's also poor practices at many healthcare providers where they don't know to administer a better option. They do something the expensive way and the risky way, and this can also increase litigation costs, which, again, put a burden on the system. Another thing that you may not know if you haven't been to the US is one of the ways that you cannot be turned away for healthcare is to show up at an A&E, or an emergency room, in other words. If you show up there, you have to be served, at least until they can patch you up and you won't actually fall over and die. So they're perennially clogged. And the cost of dealing with a patient there is about 5 times higher than if they'd actually gone to their GP and sorted it out the regular way. So it's enormously expensive when this happens. I could go on and on. I could probably put 20 more slides of things where costs are higher than they need to be. The key is, how do you find them? And so this is, unsurprisingly, anomaly detection. Again, the model that UHG uses is quite complex, and it's also proprietary and not something I'm even aware of or can disclose, but I know elements of it. But effectively, they use a combination of supervised and unsupervised learning. They built quite a sophisticated model, and they're taking into account a number of different elements. This is what we don't want. So the goal here is really to align. It's not to just pick out the most expensive things and cut them. You cannot do that, right? Otherwise, you're going to prevent healthcare for people dying of cancer and so on. So what you really want to do is find appropriate care. This is obviously inappropriate care. To do that, you've got to combine a lot of different things. So that includes information coming back from the hospitals. So all the coded information, actually in the US, they're very good about this. Every single thing gets coded. All the coded information that gets tracked in a patient, their outcomes at different times, which again are coded. Over time, so done in a timeline, time series data. Information on call center data. So when someone calls in and says, I need to claim somewhere, I need to claim for something, that's tracked. All of this stuff is integrated together in this machine learning model. And that's done as a service. And it's done principally, there's multiple groups in UHG using our technology, using MapR's technology, but the principal one is called payments integrity. But it also takes into account how well the treatment works for people. So in other words, it may be that something's very expensive, but the outcome of that is very good. So that doesn't get flagged. What they're looking for is 10 patients received this treatment. It was very cheap. They ended up fine. You gave them an expensive treatment. It doesn't mean they'll necessarily stop it, but they'll certainly look into it. And that's really what the model's for, is to try and use people effectively to look at whether claims are legitimate or not, what needs analysis or not. But it does take into account patient outcomes. It's got one of the best ROIs I've ever seen. For every dollar they put into this, they get 22 back. And they get to put most of that into affordable care. So they put a lot of that, some of it does go back into profit, but most of it goes into allowing other people to come in at lower premiums. So it does actually have a really big impact. And again, this is the biggest insurer in the US. So it has a material impact on people's lives to the tunes of tens of millions of people. Aadhaar, this is the other one I'm going to talk about. This word is synonymous with identity. It's the world's largest national ID project. Begin thinking about how you use your identification here in the UK. They've issued now, they've almost reached completion. It's now starting to tail off, and the rate in which they're taking in new identities is slowing, but they've already done over 1 billion Aadhaars issued. Tens of millions now have access to benefits that would not otherwise have had them, and that's very important in a country like India. We want those benefits to get out because it actually improves the lives of people and improves the economy of the country at the same time. Everyone needs an identity, Use them for so many things. Travel, every time you need to prove your age for something, every time you need to get access to government benefits. For banking, if you need to set up an account. Insurance, it's almost limitless. Buying a house, it never ends. Some people need multiple identities, but you've got to have at least one. Typically for most of us, that's a driving license and a passport. In India, there's a lot of different IDs. Now, one of them mentioned up here is Aadhaar, but there were a lot of other ones as well. And many people had none at all. There just was no identification. And so access to those services was effectively prohibited. That's exactly what Aadhaar is designed to solve. Voting, so that's one I didn't mention before, something as basic as that. The means with which one shows how one has a right to a vote, that was something that was very complex before. It was very difficult to eliminate duplication. It was very difficult to eliminate fraud. And many people simply didn't vote because they didn't have papers for it. That's something that Aadhaar fixes. Access to programs like apprenticeship programs, unemployment benefits. Not only does this allow for them, for people to actually obtain them, but it actually allows for things like direct payments. So it means that instead of going through a middleman or having people go somewhere to get the money, we can actually send it to them directly. And this means it actually gets used, which again is very good for the economy. That's exactly what we want. So that's a huge benefit there as well. Healthcare moves from being reactive to proactive. So in addition to being greater availability for the population, more people can actually access the services and healthcare actually improves. It actually means that we can actually push healthcare out. So we know who people are, we can identify them, and we can actually look into their healthcare records and determine what needs to be done next. And here India is actually leapfrogging the West in many ways. So many programs that, I mean, even here, proactive healthcare is something that we're still evolving into. The idea of what's possible here with this program is really imaginative, I should say. It's something that really means that with things like diabetes and other similar diseases can be actually managed in a far more proactive way by pushing the healthcare out to the edge. So how is it done? Fingerprints, iris, your name, your face. These things are combined together and stored in MapRDB, which is our database. Just think of it as a NoSQL database with an HBase API. But these pieces of information are stored for you in multiple tables that reference each other. And because of the use of the iris, it's extremely hard to forge, which is obviously very critical for an authentication system. There's two sets of technologies used, one for actually obtaining the information. This is what they've been using over the last 8 to 9 years to actually collect the information. And then another set to actually authorize. And this is where, at somewhere like a government benefit center, you would actually go and rescan. That will get sent to MapR, where using a series of algorithms, it actually identifies the rows in the database that represent your iris and that represent your fingerprints and verify that you are who you say you are. This is literally how they collect the information. Sometimes this is sent around in vans, but effectively these offices are set up with this information to capture as quickly as possible. That means for the database, a lot of write performance as well as very low latency on reads. The ability to retrieve information quickly is absolutely critical, and so it has to scale. I won't get into some of the other elements around data protection and so on, but the key thing is simply the scale of this system, right? It's over 1 billion people. And so this database is in constant use. It never ends. The response times required of this are simply tremendous. On the back of this, is in addition to obviously storing and retrieval and authentication on the back of those images, analytics are also possible. So additional information can be tied to that, and they do indeed do this. So for instance, with the unemployment benefit system, that information is actually linked and joined into those tables. And then they're able to run analytics on that using Spark and provide information back. And they use everything else. I could show you an architecture diagram, but they're using Elasticsearch and Solr and Spark on top of that, Spark streaming, to combine this information together and run analytics. And it's being used everywhere. This is a database that's used all over India, and so the information is actually publicly available. obviously not the copies of your irises, but the other information is available to other government agencies that can combine it with their own data and do things like eliminate fraud, eliminate duplication, prove identity, and so on. Questions? All right. Thank you.